Hello and welcome to the Maths Matrix and part 2 of the fractions series. In this video we'll be doing adding and subtracting fractions and you'll need paper and a pen. I'm not going to put a list of questions on screen for you to check because people quite often tell me in lessons that they can add and subtract with fractions, and then when I actually give them one to try, they can't do it after all and they only thought they could. So we're just going to get right on into the lesson and then I'll give you the questions at the end. So if you put a title of fractions, or if you already did lesson 1, just continue on in your notes. And then put a subtitle of adding and subtracting fractions. And then put before two fractions can be added or subtracted. They must be expressed over a common denominator. And that is how you add and subtract fractions in a nutshell. So if you're quite close to your exams, I would suggest that you write that on a flashcard and learn that, because that one sentence literally tells you most of what you need to do when it comes to adding and subtracting fractions. So we'll just go ahead and do some worked examples now, which you can label up with a few more notes if you need to. So if we put e.g., let's have 3/8 plus 2/5. Okay, so if you copy that one down. And then we say before two fractions can be added or subtracted, they must be expressed over a common denominator, which means the bottom numbers have to agree, and at the moment these don't. You can always find a common denominator by multiplying these two numbers together. So if you weren't aware of that, at the side just put an arrow and then actually put, you can always find a common denominator by multiplying the two denominators together. And then 8 times 5 is 40. So what I'm going to do next is I'm just going to set up two denominators that are both going to be 40, and I'm going to put the plus sign between them. So that's always what I do first. And then to get from here to here, I've multiplied the bottom number by 5. So because I've multiplied the bottom number by 5, I need to multiply the top number by 5 as well, which is going to give 15. And that's because 3/8 and 15/40 actually represent the same size thing. So if you were to get a cake, cut it into 8 slices of equal size and remove 3 of them, and you were to get a cake of the same size and cut it into 40 equal slices and remove 15 of them, in each case you would be left with the same amount of cake. It's just that this is a scaled up version of that. So it represents the same portion, it's just been scaled up. And we're going to scale this one up similarly. So to get from 5 to 40, we've multiplied by 8. And so in order not to change the actual size of the fraction, we're just going to make it look different. We don't want to change the amount of cake it represents effectively. So to get from 5 to 40, we've multiplied by 8, and therefore I need to times the 2 by 8 as well to give 16 over 40. And then at that point, I just add these numbers together. So 15 plus 16 is 31. But I'm still working with 40ths, so we don't add the bottom numbers together. again, thinking in terms of cake, if I have 15 40ths of a cake, so 15 slices of cake out of a possible 40, and I add to that 16 slices of cake out of the possible 40, then altogether I have 31 slices of cake out of a possible 40, so you don't change the bottom number. So if this is quite new to you, again, put an arrow there and put add the top numbers, but don't add the denominators. And then in this case, we can't cancel down 31 over 40 because 31 is prime. So that is as simple as that answer gets. It won't cancel down any further. I'll show you another one. So if you do e.g., let's have 1/15 plus 1/2. So before two fractions can be added or subtracted, they must be expressed over a common denominator. And we can find a common denominator by multiplying the denominators, and 15 times 2 is 30. So I can set up my denominators there like that. To get from there to there, I've multiplied by 2. So I need to times 1 by 2. To get from there to there, I've times by 15. So I need to times 1 by 15 as well. And then 2/30ths plus 15/30ths gives an answer of 17/30ths overall, which again won't cancel. So that's the final answer. I'll show you another one. So if we do e.g., let's have 5/12 plus 2/7. So before two fractions can be added or subtracted, they must be expressed over a common denominator. And 12/7 are 84. So in this case, a common denominator can be 84. To get from 12 to 84, I've multiplied by 7. And 5 times 7 is 35. To get from 7 to 84, I've timesed by 12 because 7 goes into 84 12 times. So 12 times 2 is 24. And then I'm going to add those up. So 35 plus 24 is 59 over 84. Will that cancel? No, I don't think it will. So that would be our final answer for that one. This time we'll do one with a takeaway. So if you put e.g., 8/9, take 3/4. And then we wrote in our notes, before two fractions can be added or subtracted, they must be expressed over a common denominator. So we still need a common denominator, and we can get one by timesing 9 and 4 to give 36. So I can set the denominators and the takeaway up ready. To get from 9 to 36, I've multiplied by 4. So I need to times the 8 by 4 as well to give 32. To get from 4 to 36, I've multiplied by 9. So I need to times the 3 by 9 as well to give 27. And 32 take away 27 is 5. And I'm working in 36ths. And that won't cancel, so that's my final answer. Again, we don't subtract the denominators, because if I have 32 slices of a cake that was cut into 36 and I have 27 slices of a cake that was cut into 36 and I subtract, I have 5 slices left of a cake that was cut into 36, so the denominator doesn't change. So adding and subtracting are really done in exactly the same way, except in one you add at the end and in the other you take away at the end. But in both cases you need that common denominator, okay? I'll show you one more with a takeaway. So if we have, let's have 19/20, take 1/3. So 20 times 3 is 60. So I'll set up my fractions over 60. To get from there to there, I've times by 3. So I need to times 19 by 3, which is 57. If you don't know what 19 times 3 is, then that's where your long multiplication can come in and you can work it out to one side. To get from there to there, I've times by 20. So I need to times the 1 by 20 to give me 20 over 60. And actually doing the takeaway, 57 take 20 is 37, and I'm working in 60ths. So that's the final answer. And when you're doing these, I strongly suggest that you actually do put these lines in, at least until you get very familiar with it, because it just helps you to keep track really of what's going on where. So it's absolutely fine to put these in and to put those bits in. And I strongly suggest that you do actually put both of those bits of working in, because if you were to mess up the final takeaway, but you had those in, the examiner would be able to award you some method marks. Whereas if you'd tried to do the whole thing in your head and then you'd just got your answer, but you'd made a mistake, you couldn't have any method marks at all. So it's really important that you show this line of working. And I suggest that you put those little lines in as well that show what's happening, at least until you get very smooth at doing them and you become really confident at doing them. All right, so that is adding and subtracting fractions. If you're aiming for one of the higher levels, or if you're on A level and you're watching this video for some reason, all of this that I've done with adding and taking fractions applies equally to algebraic fractions, not just to fractions in number, which is why it's especially important that your fractions work is very strong if you're going for one of the higher grades or if you're doing A level. Well, thank you for watching this video, and I will see you in the next one where we will be doing multiplying and dividing with fractions.